Superconductors. In 1911, H. Kamerling found that the resistivity of mercury drops zero at 4.2 Kelvin temperature and converted into a superconducting material have excellent conductivity. The ability of certain metals and alloys which exhibit almost zero electrical resistivity, maximum conductivity when they are maintained at low temperature. This phenomenon is known as superconductivity. The material which exhibits this kind of superconductive property is also known as superconductors. Superconductivity defining properties. Critical temperature. For mercury, it is 4.2 Kelvin. Below 4.2 Kelvin, the mercury behaves like a superconductor. The resistivity becomes zero and the conductivity is maximum. At a particular magnetic field, the superconducting property exists. Beyond the magnetic field, the superconductor becomes a normal conductor. That particular magnetic field for a particular material is known as critical magnetic field. As we know that the conductivity is infinity, even though that beyond a particular current, there will be a magnetic field is produced beyond the magnetic field, then the superconductor becomes a normal conductor. That particular current value is known as critical current density. For a superconductor phenomenon to be occur, the temperature should be below the critical temperature, the magnetic field should be below the critical magnetic field, and the current density must be maintained below the critical current density. The graph shows the resistivity varies with temperature. The x-axis the temperature and in y-axis the resistivity. For normal conductor, even the temperature is reduced. For example, Ag is taken. Even below, even at zero temperature, there may be a resistivity in which it has resistance. There will be a poor conduction. But for a superconductor, for example, tin, if we are decreasing the temperature, a particular temperature, the resistivity suddenly becomes zero. That temperature is known as critical temperature. Below this critical temperature, the resistivity is zero. The tin behaves like a superconductor. During the critical temperature, the resistivity falls to zero. That is known as transition temperature, in which it transforms from normal conducting state to superconducting state. The temperature at which normal conductor becomes a superconductor is known as critical temperature. During the superconducting phenomena, the electrical resistivity drops to zero at critical temperature. The magnetic flux lines are excluded, like diamagnetic materials which are ejected out from the superconductor. It behaves like a diamagnetism. This property is mainly used in magnetic levitated train which has 400 plus km/h speed. There is a discontinuous change in the specific heat of the metal, and there are small changes in the thermal conductivity and volume of the material. Some applications of superconductor. Superconductors can be used in switching device. Since the current is maximum, resistivity is low or zero, switching can be possible at a faster rate. It can be also used in mercury or storage element in computers. They are used in designing cryotron, switching device, magnetic levitated train, in which the train floats above the rails, Josephson devices, and squid. Thank you.